Okay, last but not least, we're going to talk about temperature. So this is important to understand, is that the temperature of an object is the average kinetic energy of its molecules. Probably should have said that first. So you've got molecules running around with different speeds in a gas, let's say. That's normally how we think about it when you think about the ideal gas law or something like that. You have all of these guys running around at different speeds. In a lattice, each little atom is vibrating, right, like that. So this is what happens in a solid, is each atom on average stays put and it vibrates, and it has the kinetic energy from the vibration, how fast each one of these little guys is vibrating, and that's what causes the kinetic energy in the solid. So one way to talk about this is the mean molecular kinetic energy is the temperature. Okay, so let's say that E is equal to N times kB T. This is the Boltzmann constant. Which I forget right now. But you see, this is the total energy here. This is the number of molecules. Right, so your average energy is just going to be your total energy over the number of molecules, which is equal to this thing called the Boltzmann constant times the temperature. And that sort of tells you what the Boltzmann constant is. It's sort of the conversion from Kelvin, or degrees C, per molecule to joules, temperature, or Kelvin to joules per molecule. So this is the Kelvin to joules transition. It's just a scaling constant. It's just a conversion constant that has some fundamental meaning because of the way we define temperature, right, statistically, as related to the energy. The other thing we have to worry about is the change in the energy. So if we have our initial assortment of atoms flying around with all their different velocities, if we want to heat that up, if we want to increase the internal energy, or we want to increase that temperature, we have to increase the speed of these things. So if we run over here and turn them orange, so after we speed them up, maybe not all of them, but most of them are sped up. Maybe some of them change direction a little bit and slow down, but most of them speed up, and so they have longer arrows. Do something like this. Now this is your specific heat. It's the amount it takes to raise the amount of energy that it takes to raise a gas a certain temperature. And this is measured with mass. So it's how much you're measuring the quantity with mass. Over here we're measuring the quantity with number. And you'd have to figure out which is which by volumes and densities and stuff like that if you wanted to convert between them. And this is the changing of the energy. That's how much you're heating the gas up. All right? So next we'll give an example. Bye now.